Have you ever wondered how your bank seems to know exactly what you need, sometimes even before you do? Well, it's not magic. It's the power of data analytics, and it is completely reshaping the entire financial industry. So let's dive into how banks are turning these mountains of raw numbers into incredibly smart decisions.
Okay, here's our game plan for today. First, we're going to lay the groundwork and understand what a data-driven bank even is. Then we'll get down to basics. What is data, really? After that, we'll start climbing the analytics power ladder to see how raw info gets turned into real action. And finally, we'll wrap up by looking at the science that makes this all happen, data science.
All right, before we get into all the complex algorithms and machine learning, let's start at square one. What does a bank actually do? It's probably simpler than you think, and it's the source of what's become the most valuable asset in modern finance. And that's really it. When you boil it all down, a bank takes in money and it lends money out. But here's the key. Every single one of those transactions, whether it's a tiny deposit or a huge business loan, it generates a data point. This constant stream of information is the bank's secret weapon. It's the raw material for all the powerful stuff we're about to get into. And just look at this. This is only one side of the business. You've got everything from overdrafts and cash credit to housing finance and student loans. Each one of these has its own unique data signature, creating this incredibly rich tapestry of financial behavior that's just sitting there, waiting to be analyzed.
So we keep throwing this word data around, but what does it actually mean to an analyst? You know, it's not just some big, vague cloud of information. It comes in very specific forms, and those forms dictate exactly how you can use it. First up, we've got the most common type, and the easiest to work with, structured data. Just think of any spreadsheet you've ever seen. You've got clear columns, right? Customer name, account balance, transaction date. And then you have rows for each entry. It's clean, it's organized, and it's really the bedrock of traditional analytics.
Now, on the complete other end of the spectrum, you have unstructured data. This is the messy, complicated stuff from the real world. We're talking about the text from a customer complaint email, a scanned image of a document, maybe even the audio from a call to customer service. It is packed with valuable insights, but man, it is much harder to get your arms around and analyze.
And then, of course, there is the middle ground, semi-structured data. An email is the perfect example. It has some structured parts like the to and from fields, but the body of the message, that's just free-form unstructured text. This hybrid nature means you need some special tools to really unlock all the value inside. Now, beyond its structure, we can also classify data by its value. So you have discrete data, which has a limited number of options, like there's a specific list of loan types. And then you have continuous data, which can be any value within a range. Think about an interest rate. It could be 2.5%, it could be 2.51%, or even 2.513%. Knowing this difference is absolutely crucial for picking the right kind of analysis. But here's the reality check. Data in the real world is almost never perfect. It's what we call noisy. You'll have incomplete fields, like an optional middle name that's left blank. You'll have noise, like impossible values entered by mistake, a negative age, for example. You'll see inconsistent formats all over the place, like different ways of writing a date. And sometimes you'll even find intentional placeholders, like setting an expiry date to the year 9999. A huge chunk of a data scientist's job is just cleaning up this mess.
Okay, now for the really cool part. Once you have all this data, clean, messy, structured, whatever, how do you actually make it useful? Well, this is where we climb what's called the analytics power ladder, moving from just basic reports to powerful, automated decisions. And this is the fundamental question, isn't it? Every single company is facing this. Having the data is one thing, but turning it into actual intelligence, that's a whole other journey. So let's take that first step. The very first rung on our ladder is descriptive analytics. This is all about looking in the rearview mirror. It's focused on answering one simple question: what happened? A pie chart showing sales by quarter is the classic example. It gives you a clear snapshot of what's already taken place. Next up, we climb to diagnostic analytics. This goes a layer deeper. It's not just about what happened, but why it happened. So let's say you see a dip in loan applications in one quarter. Diagnostic analytics is what lets you drill down from the year to the month to a specific week, maybe even to an individual branch to find the root cause of that problem. Now we're getting to the really powerful stuff, predictive analytics. This is where we shift our gaze from the past to the future. It uses all that historical data and statistical models like this linear regression you see here, which just finds trends in data, to answer the question, what is likely to happen next? This is where machine learning really starts to shine, letting banks predict things like which customers are probably going to need a car loan in the next 6 months. And finally, we've reached the top of the ladder, prescriptive analytics. This is the ultimate goal. It doesn't just predict the future, it tells you what you should do about it. It might suggest the perfect interest rate to offer a specific customer to make it most likely they'll accept the loan, while also maximizing the bank's profit. It creates this amazing feedback loop for smarter and smarter decisions. So, what do you call the field that brings all of this together? The discipline that combines statistics, computer science, and business know-how to climb that whole ladder? Well, that is data science. Data science is a huge, sprawling field, but it really stands on these core pillars. It covers everything from the nuts and bolts of how data is stored and kept secure, to the deep statistical analysis and machine learning models we've been talking about. And of course, it includes the programming skills to make it all run and the business intelligence to turn those technical insights into real-world action. And even if you just look at the data analysis piece of the puzzle, there's a very structured approach. You've got qualitative methods for understanding the why behind the data, like analyzing customer feedback. And then you have the quantitative methods for the hard numbers, like running a test to see which marketing campaign was actually more effective. It's a science that uses different tools for different kinds of problems. And you should make no mistake, this is not some small niche trend. As Tim O'Reilly puts it, this transformation is fundamental. It's bigger than the first wave of the internet. For the banking industry, it's not a question of if they'll become data-driven, it's a question of how well and how fast they can adapt to this new reality. So, we've seen how banks can turn a simple transaction into a powerful prediction. From the personalized loan rates you get offered to the fraud they can prevent before it even happens, data is at the absolute core of the modern financial world. But as the science gets even more powerful, the real question becomes, how will it shape your financial future?